Okay, welcome back to math class. Let's take a look at these 3 questions that were in at the end of that YouTube video. Answer each of the following probability questions and tell whether it was experimental or theoretical probability that you calculated. Number 1, your sister was late to pick you up from school 9 times, and she was on time 13 times in the past 22 days. What is the probability she will be late today? So, how many times did she pick you up? So if we add the 9 and the 13 together, we get 22. So that's where that past 22 days comes from. And so what is the probability she will be late today? So is this in theory or is this based on something that has actually happened before? So this is an example of experimental probability. This truly happened. Out of 22 days, she was late 9 times. She was on time 13 times. So what's the probability she will be late today? So let's look at the way we're going to solve that problem. So she has been late 9 times out of 22 times that she has picked you up. So 9 out of 22, that does not simplify. The factors of 9 are 1, 9, and 3, and none of those go into 22, with the exception of 1. But if we divide both of those by 1, it does not simplify that fraction. So 9 over 22, and let's take a look. So if we needed to make that a decimal, that would be, we probably would need to round that because that is a repeating decimal for 090909. So decimal for 09, and the 09 repeats. And so that would be 40.9 with those 2 numbers repeating percent. So depending on how you got your answer, this probably would have been the way you would have done that, and that is experimental. I am having problems with my writing and spelling today, so forgive me. Okay, let's go back. Let's look at the second one. You have a normal 6-sided die. What is the probability of rolling a number that is greater than 2? So notice it doesn't say roll it 20 times and see how many times you land on a 2. It is looking for the theoretical probability. This is, we know all of the outcomes. We know the outcomes are 1. Let's switch over. Number greater than 2. So our outcomes are 1, 2, 3, 4, 5, and 6. And what's the probability of landing on a number greater than 2? So the theoretical probability there is 1, 2, 3, 4. 4 out of 6 sides. And that is also probably not one that we would change to a decimal because you are going to get a repeating decimal, but we'll look and see what that would be. 4 divided by 6, and you get 0.6 repeating, or 66.6 repeating percent. So in this case, you would probably just leave it as that fraction. And again, this one was theoretical. Theoretical probability. And let's look at the last one. Your mom gave you dessert with dinner 2 times and didn't 10 times since you started keeping track. What is the probability you will get dessert tonight? So This is something that actually happened. You started keeping track. How many dinners did you keep track of? Well, if it was 2 that she gave you dessert and 10 she didn't, then you've been keeping track of the last 10 dinners. So what's the probability you will get dessert tonight? So this is not theoretical, this is experimental, because this is based on data of something that has actually happened. And so she gave you dinner 2 times out of 12. So what is that going to look like for probability? That is going to look like 2 out of 12. Which simplifies to 1/6, which is also going to be a repeating decimal. Are you noticing here when you have a 6 as a denominator, you're going to get a repeating decimal? That is just a math fact. 1 divided by 6, you're going to get 0.16 repeating, or 16.6% with that 6 repeating. And so because this is something that actually happened, we are basing that on experimental data, that is experimental probability. Okay. All right. So if you got all those right, you were off to a great start. If you had some trouble with it, that's okay. We're going to do some practice. We're going to go to IXL, and let's go to DD.4. These are all based on experimental probability. Donut Haven recently sold 6 donuts, of which 2 were jelly filled. What is the experimental probability the next donut will be jelly filled? So write it as a fraction. So 2 out of 6 simplifies to 1/3. It's important on these problems that you notice and calculate the total number of donuts. So the total sold in this one was 6. So 2 out of 6, which is 1/3. We're going to have some where you've got to do that calculating on your own. A blue and orange spinner landed on blue 2 out of 18 spins. What is the experimental probability the next spin will land on blue? So the total number of spins was 18, and you landed on blue 2 times. 2 out of 18, which is 1/9. And let me see if I can find one that's a little bit different. So this problem is a little bit different in format, so let's read it. Yesterday, a car rental agency rented 4 pickup trucks and 4 other vehicles. What is the experimental probability that the first vehicle rented today will be a pickup truck? So what we've been doing is just having the 2 numbers and putting one as the numerator and one as the denominator, but we have to look at how many total vehicles were rented. How many different things did they rent? Well, if 4 were pickup trucks and 4 were other vehicles, then that really means that they rented 8. They rented 8. So you're having to add those 2 things together. So 4 trucks plus 4 other equals 8 in total. So this is going to be our denominator. This total of 8 is our denominator. So our probability, our experimental probability, is 4 out of 8. And 4 out of 8 simplifies to 1/2. So you've got to make sure that you look at these questions to see if they give you the total or if you have to figure the total. And the higher your score goes on this one, the more you're going to have to pay attention to, do you need to add the 2 things together? So if you start missing them, I would think this is what you're going to want to pay attention to and see if that's what's giving you trouble. So 1/2. A coffee shop recently sold 12 drinks, including 2 cappuccinos. So do you see that the total is 12 and it includes those 2? So it's not 12 others and 2 cappuccinos where you have to add them together. So 2/12 simplifies to 1/6. Tasty Things Bakery recorded the desserts that were recently sold. So they sold 2 cookies, 7 slices of cake, and 1 cupcake. What is the experimental probability the next dessert sold will be a cookie? So we've got to find the total number. So when we look at our samples here, our sample space, and our responses in this experiment, how many total items were sold? So you have to add the 2, the 7, and the 1, and when you add those together, you get 10. So they sold 10 total items, and how many of the 10 were cookies? 2. So 2/10 simplifies to 1/5. This one is the same. Let me see if I can find any others that look different. Okay, let's try this one. Reed works at an appliance store. He recently sold 10 dishwashers and 10 other appliances. What is the experimental probability that the next appliance Reed sells will be a dishwasher? So how many total appliances did he sell? Well, he sold 10 dishwashers and 10 that were something else. So how many did he sell in all? The total is 20. And what's the probability that out of those 20 he will sell dishwashers? Well, that's 10 out of 20, and that is 1/2. 10 out of 20 is 1/2. So I think these are all, from here on out, pretty much the same. So what I want you to do is really, when you read a problem, think, what is the total number that they're talking about? It's not always the larger number. Sometimes you're going to have to do some adding. So that is DD4. Let's go back and let's look at DD6 now. Now it's making predictions using theoretical probability. Let's see what these problems look like. If you roll a 6-sided die 6 times, what's the best prediction for the number of times you will roll a 5? So now in our last unit, we looked at using probability to make predictions. And so we're going to use that same idea. So a 6-sided die, you're going to roll it 6 times. What's the best prediction for the number of times you'll roll a 5? So that 6-sided die, there are 6 possible choices. And the question is, was it just rolling a 5? So how many 5s are on that dice? 1. So this is our probability. Now we can make a prediction. Do you remember setting up a proportion? So if we run this experiment 6 times, what is the probability that we're going to roll a 5? Well, 1 times 6 is 6, and 6 divided by 6 is 1. Really, 1/6 is equivalent to 1/6. So this is what we're going to use to answer the question. And as you get better at those, you're not going to have to write them out. So what is the best prediction for the possible number of times you'll roll a 5? 1 time out of 6 rolls. You select a marble without looking and then put it back. If you do this 8 times, what's the best prediction for the number of times you'll pick a pink marble? So let's see how many marbles there are. 1, 2, 3, 4, 5, 6, 7, 8. So our probability of choosing a pink marble is 1 out of 8. 1 out of 8. So the probability is 1 out of 8. So the prediction is, if I do that experiment 8 times, how many times am I going to choose a pink? Well, 1. 1 out of 8. So you'll notice if your total is the same number as the times you're going to run the experiment, your numerator will be the same. Sometimes you're going to have to run this a few times to go, oh, I see what they're talking about. So there's 1 pink out of 8. So if you do the experiment 8 times, you should theoretically pick a pink marble 1 time. You roll a 6-sided die 6 times. What's the best prediction for the number of times you'll roll an even number? So there are 3 even numbers on a dice. So 3/6 is even. So if you roll the dice 6 times, you should get an even number 3 times. Do you see what's happening? If you roll a 6-sided die 12 times, what's the best prediction for the number of times you'll roll a 5? So the probability of rolling a 5 is there's one side that's a 5 out of 6. So the probability of rolling a 5, the probability is 1/6. There are 6 sides and there's 1 5. So the probability is 1/6. So if I roll that experiment, if I do that experiment 12 times, how many times would you predict that you would roll a 5? So I could say, well, that's times 2. So 1 times 2 is 2. Or you could cross multiply. 12 times 1 is 12. And 12 divided by 6 is 2. So either way you choose, your answer is you should predict 2 times out of 12. So we're just using probability to make prediction. If you spin the spinner 6 times, what's the best prediction? What is the best prediction possible for the number of times it will land on yellow? So how many different parts are there? There's 1, 2, 3, 4, 5, 6. So 6 total sections or possible outcomes. There are 3 yellows. So if I spin that 6 times, I would expect to land on a yellow 3 times. If you flip a coin 8 times, what is the best prediction possible for the number of times it will land on heads? So we're going to flip that coin 8 times. So heads there are 2 possible choices. One's heads and one's tail. So heads would be 1/2. 1 out of 2 times. 1/2. 50-50 chance. If we do that, was it 8 times? So if our total number of flips is 8, how many times would you expect it to land on heads? 1 times 8 is 8. 2 times 4 is 8, or 8 divided by 2 is 4. So we would expect that, theoretically, we would expect that to land on heads 4 times. So I think that you've got this. Make sure that you are writing things down and setting up your proportions, and that will be key to solving this section. If you have any trouble, send me or Mr. Millwood a message, and we will see what we can do to help you out.